Hello, everyone, and welcome back to the final day of Edge Global Week. I am delighted to be joined now by Vijay Karthikesu, who is the CEO for Swarmio Media. And without further ado, I would like to hand over for him on the case study on Edge Gaming.
Thank you. Thank you very much. Hello, everyone. I'm Vijay Karthikesu. I'm the founder and CEO of Swarmio Media. Thank you very much for joining me today. We're going to talk about how we are using edge computing technology to deliver a gaming solution to gamers using telecom operators. So let's move on. And next slide, please. Swarmio Media is a Canadian company. We're a Canadian technology company. We deliver a solution to telecom operators that they can go and monetize, reach out and monetize millennials and digital natives using gaming and esports. And all these solutions are delivered from an edge computing point of view. Next slide, please. So we use two main technologies to deliver our solutions. One is Swarmio Matrix. This is what we are going to talk about today. This is our latency optimized edge computing platform. This is specially designed for delivering real-time applications, especially gaming needs, whether it's a game server or cloud gaming, or we are talking about streaming solutions. And Swarmio Hive is an application that monetizes, an application that runs on Swarmio Matrix to deliver that end user experience for gamers. So it is a monetization application for the edge computing platform. Next slide, please. So before we go deeper into what we are doing, let's kind of step back and talk about. I think most of the people joining here knows what is edge. Just let me recap. Edge is where we process computing closer to the user or closer to the thing or closer to the need. Instead of processing applications or data in the centralized cloud like Amazon and Google or Azure, we are now talking about processing those applications at the edges. Why? What are the needs or what are the forces shaping the need for this? And there are four main forces actually shaping the whole edge platforms. Number one is latency. More and more, I think we all know that we use real-time applications every day now. Like this seminar here, we are delivering a real-time presentations. There are lots of people doing Zoom and other video conferencing. Gaming, you have everyone, more than 50% of the world actually play games today. And every application becoming more and more real-time. We are talking about IoT, autonomous vehicles, drones, and everything needed real-time response. So latency is the killer. So latency, there are lots of things that affect latency. So the idea of reducing the latency is let's bring the processing closer to the need, then we can reduce latency by eliminating the travel distance, number of hops, and lots of other things that we can actually reduce latency. Latency is one of the main factors of the forces that pushing the data processing closer to the edge. The next one is bandwidth. So what happened is with the cameras, we take lots of photos and there's surveillance camera everywhere. If you go to the airport or you kind of walk in the street and everywhere, everything is monitored. And there are sensors and autonomous cars, when they drive, they're going to generate tons of data by sensors and videos. All of this data is actually being created at the edges. And it's actually a flip. So it used to be, you probably heard about CDNs where the content is, the movie content like Netflix and everything is processed somewhere in a centralized data center and pushed to the edges for people to consume. But now think about the data, the direction from centralized cloud to the people. Now it's kind of flipped. Now the edges are generating lots of data, and you have to take that data back to the centralized cloud to process it. That takes lots of bandwidth from the access layer, where bandwidth is actually is very expensive, especially in the backhauling and bringing everything back to the data center. So this is something is causing, but we, instead of bringing all these data back to the centralized data center, I think it's better to process it at the edge and then only send the data what is needed to the centralized data center for analytics, or only the metadata. So that's bandwidth is another force that's forcing us to process data at the edges. The other one is privacy and security. I think this is a common kind of law of the land regulations, whether it's a healthcare data or privacy and security data. There are many reasons that you want to keep the data and the applications within the premises or within the borders. There are many areas that you want to kind of keep it. So that's kind of, it's one of those things that's been there forever. This is the reason why most of the companies used to run their own data centers in their premises. Now that is there. So that's kind of one of the main one to have control. The last, but not the least, is limited autonomy. Murphy's Law says things fail. So if you have a drone, or if you have a health monitoring system or manufacturing robot that's doing things, and it will be connected to the cloud and it will be connected through the network, but things fail. So the network can fail, the cloud can fail. So if you have a car driving autonomously, if the network fails, you still want the car to drive or the drone to fly. So there has to be certain intelligence must be built in at the device edge itself so that it can function. So that's one of the reasons the actual processing is being pushed to the edges, actually to the devices itself. So these are the four forces. So with these four forces, let's talk about how the architectures are being driven from the forces. Next slide, please. Thank you. So let's look at these four forces, how these are shaping the actual architecture, because cloud is an umbrella term, and everybody thinks cloud is an umbrella term, and then edge is an umbrella term, and there are not just one edge. There are many different edge architectures based on the need, based on what we are trying to solve. So let me go from the edges. So there are edge devices, and so basically these are intelligent wearables, or what I was talking about, the robots in a manufacturing factory, or a health monitoring device that monitoring someone's health at a hospital. These things need to be intelligent enough to run itself. There are lots of sensors that can process data, smart cameras, they can make decisions. So these are the edges actually at the device, and they can operate to a certain level, but they will be connected to other layers as well. So that's one edge. So there are lots of manufacturing, lots of R&D being done. There are lots of innovative companies building these intelligent devices. Now let's move to edge on site. This is where the example is if you have a factory and there are lots of data being collected by sensors, and whether it's an airport, there are video cameras everywhere collecting videos for facial recognitions. All these data, it doesn't make sense to send all the data to outside of the building. You just want to have a small edge server on-premise, collecting all the data, processing data, giving back the results, and only send the metadata or whatever needed to be saved to the cloud. So that's an example of edge on site. Let's go beyond one layer up. This is where you put an edge computing at the service provider's edge. So these are things called MECs, multi-edge access devices, or anything that runs on the access layer or at the edges of your internet service provider or telecom operator. And these devices mainly focuses on and capturing all of these data and make sure that they are processed immediately for efficiency, mainly for bandwidth efficiency. So if you think about it, especially a telco operator from the cell side is unnecessary to collect all the data and then send it back to a data center and using all the network resources to send the data. So it's easier to capture the data at the edge, process it, give the result back, and then only send the metadata back. So these are the network edges. And there are lots of implementation being happening now, for especially when you talk about 5G, and most of the operators are looking at MECs to implement at the edge of the network. Now, one layer up, this is where the regional edge comes. And most of the real-time applications, whether it's gaming or cloud gaming or streaming services, most of the application that real-time application that need low latency today, that can be delivered from a regional data center. Next slide, please. So in a regional data center, I think people kind of think now, okay, that sounds really latency, long latency. Let me talk a bit about what is low latency. This is another word that everybody thinks that low latency has to be sub-millisecond or nanoseconds. So the issue with the low latency, if you're talking about high frequency traders, yes, they think about nanoseconds. But now we are talking about just application, real-time applications that kind of runs on let's say gaming is a good example, or cloud streaming. Any of these applications, 20 milliseconds is more than enough. Let me tell you what that 20 millisecond is. So even if it's a car, let's say autonomous car, if an autonomous car is driving, and in 20 milliseconds, let's say it's driving at 60 kilometers per hour. In 20 milliseconds, it would have just moved around 34, 35 centimeters. In 100 kilometers per hour, it would have just moved around 60 odd centimeters, so very small. So 20 milliseconds is actually more than enough to even support an autonomous car or a drone that's flying at 100 miles per hour. So let's compare this 20 millisecond to human response time. As human, for us to see something and react to it, it actually takes more than 350 milliseconds. So that's our average human response time. 20 milliseconds is so faster than that. So with 20 milliseconds, we can support any real-time applications that exists today and also is going to exist in a near time. So this is where we focus on regional edge. The reason is the regional edge actually exists today. It's not used as an edge, but it is actually exists. If you think about every major city has a data center. Every telecom operator have their distributed hub sites and all centralized COs. And every city, they have these computing processing locations that can be used as a regional edge. And especially as a telecom operator, they can control the last mile latency because they own the last mile. They can deliver a less than 20 millisecond latency from a regional edge. And this is for anything like gaming or cloud gaming, 20 milliseconds is more than enough. This is my definition of low latency. So that, when you talk about low latency, it is not that hard to achieve that low latency. This is where that Swarmio, we focus on regional edge because it's easy to deliver, it's already there. We can go to a telecom operator and put a couple of edge nodes in their central data center and deliver less than 20 milliseconds to gamers or the application that needed today. This is a very important fact that you want to look at it. When people talk about low latency, 20 milliseconds is more than enough to deliver. But it has to be consistent. Next, please. Next slide, please. So let's talk about how we are delivering low latency for gaming. So our focus is gaming. Just a bit about gaming. So on the left, you see that the gaming internet routing, right? So from a gamer, from their computer, it goes to the telco operators or service providers backbone, and then it goes into internet and to the game service. So what happens in the internet is there are lots of zigzag routing. I don't want to go too deep into the technology, but this is how the internet is built. It's built with something called BGP, and it is designed to survive, but it's not designed to be more efficient for per application basis. Internet is a survivable network. It is reliable. It fails, it will actually reroute and it will work. But it is not designed to look at each and every application and make a best path for that application. It doesn't do that. So it's always going to take zigzag. This is the way it is built. So the problem with gaming is two things. Latency is one of the issues. So in order to do this zigzag, is going to take, and also the servers are sitting in some centralized data center, whether it's Amazon or Google or Azure, is thousands of kilometers away from the gamer, and the path it takes is going to take zigzag. So the latency is going to be one issue. The next big issue for gaming is jitter. Jitter is a variation in latency. What happens is most of the gaming, especially game clients, when they talk to the game server, they use UDP and small packets. But the whole internet is actually designed for large packets. So whether you're downloading big files or downloading movies or you're streaming with big jumbo frames. And these are the way that the internet is designed. Not just the internet, when I talk about internet, the elements or the devices that make up the internet, the routers and switches, whether it's from Cisco or Juniper or Alcatel, all of these things they are designed for large packets. All these ports in these routers, they actually work with packet per second. They don't really care how big is the packet. So these devices are designed in a way that when you have a smaller packet streaming at you, and as an input port, it actually, and especially as GDP, there are buffers in the devices. They drop them. So the whole internet. So the more devices the data have to traverse through to get to the server, it actually get more jitter. A consistent latency, most of the game servers can handle that. They can actually have an error correction and kind of think for themselves and say, if it is that latency is very consistent, they can do simple error corrections and make it work. But if the latency goes up and down because of the jitter, it's almost impossible for any game service to do that error correction. So that's why most of the gamers get lag. So it's not just latency, it's also you want to reduce the number of devices the actual packet go through. So what we do is we simply move the game server to the edge. So instead of the game server running in the centralized Amazon data center or Google's data center, why don't we just bring that game server closer to the user, to the edge of to the telco's network? So that's what we do. So we put our servers in the telco's network and work with the game publishers to move the game servers to the edge. And so now what we are doing is, instead of going thousands of kilometers, if let's say the game server is in a regional data center, for the people it's about tens of kilometers or hundreds of kilometers, you can achieve the 20 millisecond easily. And now we are reducing number of devices it touches. So it's actually reducing the jitter, so they get better performance. This is a very simple architecture to achieve, and it is achievable today. This is what we are doing. We have a global network partnering with telecom operators to build these edge nodes so that we can move the game servers closer to the user. The next problem we have, next slide, please. So when you talk about edge, now we are talking about, let's say as a game, there's going to be, even if it's a large operator, there's going to be multiple data centers. And we are talking about, we built a global edge so that the edge actually sits on multiple different service providers, networks, and globally. So there is going to be thousands of edge nodes. So the problem comes in when a gamer or bunch of gamers, usually gamers play with other gamers, right? If they are playing CSGO or any multiplayer gaming, they are playing with other gamers. When two gamers or a bunch of gamers want to play a game, now we have to think about not just closer to them, what is closer and an optimal location for all of them. That is one of the challenges that we solve. It is one of our patent pending technology. We call it latency optimized edge cloud. So what we do is we actually put a DRL agents. So it's an AI-based deep reinforcement learning agents in every edge node. It monitors all the gamers, all the edge users, and actually learns the network where these gamers are, where the edge nodes are. And when two groups of people want to play the game, it will automatically know and optimize which node will be best suited for these gamers. Let's say they are from two different, if it's US, for example, let's say one group is from San Fran, the other group is from New York, then the system will say, okay, Chicago may be the best location for them to run because it's in the middle. So it will actually optimize and pick a node to run that game server for that specific group. This is a pretty cool technology. It can be applied to anything, whether it's a Zoom or any other technology, but we are using it for the gaming. So we can optimize their server location for multiple, a group of gamers. That's our kind of secret sauce. Next, please. So with all of these things, what we deliver a platform, which is we call Swamio Hive, to the service providers. So now it comes to, we built the technology, now we need to monetize it. How do we monetize it? We need people to pay for it. So we actually have an application that we give to telecom operators that delivers many things using the edge cloud. First, optimize latency because we are bringing the game server closer. And we also host lots of private servers at the edges so that the gamers will get the best latency possible, best experience. And in those edges, we run tournaments and challenges and lots of other engaging things that's hosted in the edge. On top of that, we deliver streaming experience, especially the areas we are targeting, like LATAM and Asia. People have, so we can actually take one stream to the edge, do the transcoding, and then from that edge, we can put it into multiple, any streaming platform they want to go, whether it is Twitch or Facebook gaming or any other platform they want to go, we can actually put it in. So as a service provider, they can offer an amazing streaming solution for gamers. And on top of that, there are everything that gamers need can be delivered from the edge cloud. So this is the solution that we provide to the publishers today. Next one, please. So this is a kind of a model, this is a use case. So we are today, probably we are one of the only edge provider that really monetizing the edge cloud in a global way with very large telecom operators. And we provide the whole edge cloud and the gaming application as a turnkey solution to the telco, and telco goes out and provide that as a gaming as a service to their gamers, and the gamers pay the telecom operators. So with our platform, telecom operators can add somewhere from $5 a month to $20 a month on top of their internet service. So they will be able to, they are able to sell a gamer internet package or a streamer internet package that adds on the low latency, the edge cloud components, and also the whole fan engagement component to them as a solution, and they get paid. And then from there, we get a commission or kind of a cut from that. So this is the kind of a B2C model that we work with many telecom operators around the world today. So it's an example of how we can use an edge cloud and working with the telecom operators to monetize the edge cloud. And eventually we will move into 5G. And so this actually not just, we don't need to wait for 5G, but we can actually do this today. And also it could become a killer application for 5G. Next slide, please.
Oh, okay.
And these are the kind of market that we are focusing today, mainly LATAM, Middle East, North Africa, and Asia. And we are working with many telecom operators today. And if you are interested in talking to us, please connect with me. Next slide, please. Thank you. That's a kind of a quick kind of intro to the cloud, the Edge Cloud, and how we are using Edge Cloud to actually monetize the Edge Cloud today.
Great. Thank you so much, Vijay, for a really great presentation this, very early morning for you, afternoon for us in Europe, and evening for those of you joining us in Asia. And just as a final note, I would once again just like to thank our sponsors for making this event possible, IBM and Nebulon. And of course, Vijay, for taking the time to share Swarmio Media's case study with us. Thank you all, and we will see you all back here in about an hour and a half for the next session. Thank you, and have a lovely rest of the day.
Thank you.